All right, you're welcome to another parametric test called one-way ANCOVA. This ANCOVA test is a very important test under parametric test, even though it's not always usually used by many people because of the understanding. But we want to look at it in details, and this will help us to do a proper applications of this test. We have to use it, which area it's applicable, and for anyone who's interested in using it, you can just apply it to your data, and you see the results. Understanding one-way ANOVA is very crucial for this one because it's just an extension of one-way ANOVA. All right, so we want to first install our library. Just to, as usual, I just run this one already installed, so I just run this. So this one is by default already installed. So now one-way ANCOVA uses two numerical variables and one categorical variable. Don't forget, in the one-way ANOVA, we use one numerical variable and one categorical variable. Categorical variable that have more than two groups. Okay, for example, now gender has only two groups, male and female. Okay, but we may have other one that have more than two groups. For example, now maybe you have a age group. For example, you have a child group, you have a young adult, you have header, and so on. There are more than two groups already. So that's what I'm talking about. That's a categorical variable or factors variable that has more than two groups. So that is good for both ANOVA and ANCOVA. So ANCOVA also requires a categorical variable that has more than two groups as well. Okay, but with two numerical variables, not one. ANOVA requires one, but ANCOVA requires two. I will explain as we continue the reason why. Now let's look at the introduction first. By definition, the ANCOVA is for analysis of covariance. Is generally used to compare means of an outcome variable between two or more groups, taking into account or to correct for variability of other variables called covariates. In other words, ANCOVA allows to compare the adjusted means of two or more independent groups. All right, so the adjusted means. So in this case now, the means of the what we are doing is already an adjusted mean. In ANOVA, the means is not adjusted mean, it's normal mean, but this one is adjusted mean. So when you go further, you understand that you might want to compare test score, for example, by level of education. This is example 1 now. Okay, let me just put this one here. Okay, right. So this one, example 1, will say, okay, you might want to compare test score by level of education, taking into account the number of hours spent studying. Okay, so if you look at it very well now, we have a test score, which is our outcome, which is a variable called dependent variable. Then we have level of education, which is our categorical variable, or we call it grouping variable or factor variable. Now we also have our studying time, which is now become our covariate, so which you want to use to adjust or control the response variable. All right, so that is exactly what I'm talking about. Now, the one-way ANOVA, or ANCOVA rather, can be seen as an extension of the one-way ANOVA that incorporates a covariate variable. In ANOVA, there is not any covariate variable. That is the difference. But in ANCOVA, what to make it ANCOVA is because of covariate. That's why I call analysis of covariance. There's another variable that is involved called covariate. So this variable is the one that make a difference between ANOVA and ANCOVA, which you use to control. All right, so meaning that it combines aspect of analysis of variance, which is ANOVA, plus regression analysis, because now we are looking at the two numeric variables now, because regression deals with numeric variables, especially two or more sometimes. You can see how probably they are correlated, linearly correlated sometimes, or how they are related. So that is it combines both ANOVA and regression analysis together. So that is called ANCOVA. So this technique allows us to determine whether there are significant differences in the means of dependent variables among various groups, right? Even when considering the potential impact of covariance. Okay, so when potential impact of covariance is considered, or we can determine whether there is a significant difference in the means of dependent variable among various groups. So now, what makes ANCOVA unique is ability to consider the impact of continuous covariance. Now, want to look at consider the impact. What is the impact of the continuous covariance in the analysis? So what makes it unique? So it brings in continuous covariance in the system, and it looks at the impact. Its impact. All right. So we are going to be understanding covariance first. Okay, what is covariance? Because something might be what are you talking? What is covariance? Okay, that may be new to some people. All right. So, but I just want to quickly explain that before we go further, because in statistics, researchers are often interested, sometimes, in understanding the relationship between one or more explanatory variables, how they are related, and also a response variable. Okay, like in the regression analysis, for example. Okay. However, occasionally there may be other variables that can affect the response variable that are not of interest to researchers. Okay, they can have. So this one is called independent variable now. It's elementary variable. This is called factor variable or grouping variables now. Okay, which I have explained here. All right. This one. Okay, I've explained it. So now there may be possibility of another variable coming in, all right, to control. So we more explanatory variable and a response variable. So, however, occasionally there may be other variables that can affect the response variable that are not of interest to researchers, but they are very important, but they are not of interest. The reason why I'm not interested is because we don't need their output so later, but we want to use them at the onset to control the result we want to get later. So these variables are called or known as covariates. All right, so I can define covariate now as the variable that affect a response variable but are not of interest in the study. They have effect on response variable, but they are not of interest in the study. We don't need their result later, but we want to use them or use it to control the response variable. Okay, I'm going to go to understand later when as I go gradually. So we can say now that a covariate is like a side player in your data set. Just it's a side player. Okay, it's not the main player. That's what that means. It's a side player. Okay, it's a variable that might be affecting your main analysis, and you want to control for its influence. All right, that is what I'm talking about. So if you look at this now, let's imagine we are studying the effect of a new teaching method. Okay, our main variable of interest, that is our teaching method now. Okay, that is a factor variables or grouping variables, all right, or categorical variable now. Take note of those languages. On students' test score, all right. So that's our response variable. Okay, that's the test score, our response variable too. But you also want that student prior knowledge. Okay, we also know that student prior knowledge, which is now our covariate now, could affect their scores. All right, what they already know, what they have known before, will have effect on the score, on the current score, which is test score. So ANCOVA lets us examine the teaching methods in part while adjusting for student prior knowledge. So what we are interested in is the effect of the teaching method on the test score. Okay, how are we going to know if the test score actually have effect on if the teaching method actually have effect on test score if you don't have any mediating variable or any correcting variable or any adjusting variable there? So we call it covariate. So that is what you use to adjust for the for the teaching method. So now we say ANCOVA let us examine the teaching methods impact now while adjusting for student prior knowledge. So now let's say we want to find out if different studying techniques, for example, different study techniques which are now factor variable or categorical variable now affect student test scores, which is called dependent variable, while taking into account their current knowledge, okay, which is called That's what I just explained now. Okay, I just bring it another way so they can understand properly. Now, for demonstration's sake, in our example 3 now, we want to demonstrate now. We can say, let's now say we want to know whether or not the studying technique by students now has an impact on their exam scores. Okay, they have their several method or techniques of studying. Okay, especially for exam, but we cannot know this if this particular technique has an impact on the final exam score of students if there is no any covariance involved. That will help us to adjust, okay, for this particular response variable called test score or exam score rather. So now, but we want to account for the grade that the student already has in the class, so we use their current grade as a covariate. Okay, so this current grade that they already have before, okay, that may probably be have a linear relationship with the coming exam score now, okay, which is supposed to be, okay. So now we want to look at it. We want to use current grade they already have now as a current score, like I explained in previous examples. We are bringing in current grade, what they already have before. This time, the other time we use prior knowledge of the student. This we are using current grade of the student now, and we conduct ANCOVA to determine if there is a statistically significant difference between the mean scores of the 3 groups. So now this allows us to test whether or not studying techniques has an impact on exam scores after the influence of the covariate has been removed. So at the end of the day, we are going to remove the covariate, okay, because it's not needed in our in the final result, but we are going to use it, okay, as an adjustment a variable, okay, we call it covariate. So if we find that there is a statistically significant difference in exam scores between the 3 studying techniques, we can be sure that this difference exists even after accounting for the student current grade, okay, in the class. Whether they are already doing well or not in the class doesn't matter. It shows that there is difference because it is significant, okay. Meanwhile, there are some assumptions that comes along with the normal parametric test for each categorical test, okay. For example, now we have looked at several assumptions in the past which they are very related, okay, almost the same for parametric tests. Parametric tests come with so many assumptions, all right, but they are not always the same. Sometimes, for depending on the test we are running. For example, under this particular ANCOVA, we have and one of them is called linearity. Linearity is very important to check because it allows you to see the linear relationship between a covariate and the response variable, okay, for each group. Okay, so it helps us to see. So for example, linearity between the covariate and the outcome variable or response variable, anyone can be correct. At each level of grouping variable, this can be checked by creating a group scatter plot of the covariate and the outcome variable. We can use a ggplot to do that later as we continue. Then we also have what they call homogeneity of regression slopes. This is different from homogeneity of variance, okay? Right, so the slopes of the regression line formed by the covariate and the outcome variable should be the same for each group. This is based on grouping level. Now, these assumptions evaluate that there is no interaction between the outcome and covariance. They are different. There's no relationship between the two of them. The plotted regression line by groups should be parallel. Right? So you show that the assumption should evaluate that there is no interaction between the outcome, okay, which is response variable now, and the covariate. There's no relationship between them. Okay, they don't have any dependency. So that is what is now talking about. So we also have what they call normality, which you have done several times before. This also check the outcome variable should be approximately normally distributed. Okay, let me put this one down this way so you can see properly. Okay, so we can use Shapiro to test this. Okay, so Shapiro to test this later. So we have homogeneity of residual variance for all groups. Right, this is different from the homogeneity of regression slopes. Okay, this one, their residual are assumed to have a constant variance. It's almost elasticity. So the homogeneity of variance is coming in handy here. This is actually called homogeneity of variance actually. Okay, but we are dealing with for all groups now together. That's why we use this for all groups. So we are going to look at it based on residuals. Okay, so we also have outliers. No significant outliers in the groups, which means that there won't be any extreme outliers. There might be outliers, maybe one or two, few, but it should not be extreme. That should be tested, okay, statistically. All right. So let's look at the data set for this particular examples or demonstrations. Okay, we will conduct an ANCOVA to test whether or not studying techniques has an impact. That's a question now, or hypothesis being developed has an impact on final exam scores by using the following variables. Now, I want to use a studying variable, study method, or techniques. Let's call it techniques. Study techniques. Okay. This is called the independent variable. All right. We are interested in analyzing, right? That's our area, our interested independent variable. We have students' current grade. All right. We are going to be to adjust this covariance that we want to use to take into account. We also have final exam score, the result, the response variable or outcome variable. We are interested in analyzing. Okay, so we want to say, okay, the following dataset contain information for 90 students that were randomly split into 3 groups. Okay, 30 each. All right, so the dataset shows the studying technique each student used. The first technique is called Feynman technique. We call it TFT. The second called Pomodoro techniques, TPT. The third one we call mnemonic technique, TMT. All right. Their current grade also is included now in the class when they started using the studying technique, and their final exam score they received after using the study technique for 1 month to prepare for the exam. So within 1 month period now, the techniques has been applied after the applied technique. So we want to see the result of that techniques on the final exam score. All right, so that's one. So let's set the seed and create the data set. Now we run this line of code first. So we are trying to our data set is called studying. All right, we have data frame created now. We pass our technique here, which is have TFT, TPT, and TMT. Don't forget each of the TFT, right? Is TFT is a Feynman. Okay, we have a Pomodoro and we have mnemonics. So take note TFT, TPT, and TMT. So I will not be going to. We also be focusing on TFT, TFT, and the rest. Okay, current grade is our student current grade. Okay, we run this first. Right, so we now had the exam score. Okay, to it. So we mutate with the exam score for each of the technique. Right, so we run this. Okay, so that is what we have. Okay, so I can see where I'm doing. So we have this. We have this. This is our what do you call it now? Our data set. Okay, so you can just type this and add this. Okay, so this is all we have now. Okay, there are 2 closing brackets here. Okay, that's all. So we have our data set created. So let us explore our data. Let's explore it now and see what we have there. Okay, we just first, if you create the edge, you'll see the first 6 line. Okay, you can run this line of code. Look at it. We have a technique, we have a current grade, we have a exam score. This is what we have. Okay, so you can see here. Now you can also glimpse to see. Let's glimpse. We have 90 rows, 3 columns. Right, technique, TFT, EFT, and the rest of them. Current grade is currently exam score. So these are we have. Don't forget we have 2 categorical variable. I mean 2 response or numeric variables and 1 categorical variable. Don't forget for this particular result. I mean this can also be applied also for 2-way ANCOVA. Okay, 2-way ANCOVA rather. In that case you have 2 categorical variable here, 2-factor variable instead of having 1. Alright, so these 2 remain. Can still use these 2 to remain. Okay, you can maybe want to have like something like gender to it to see how it affects individual gender. Alright, so but let us just focus on this. Alright, so now we want to let's inspect it and look at it in form of just one each one group first in grouping method. We want to look at it. Okay, so we have a TFT, we have TMP, TPT, we have current grade, exam score. So we look at it here like this. So so that is just in form of we are trying to exploit. So let us also look at it in form of we look at the mean and the SD standard deviation of each of these things. So let's look at them. So we have a technique here. We have mean grade. We have standard deviation. We have a mean. We have a standard deviation. So this one's a grade now. This exam score. All right. So you can see the mean. If you look at here, you can see that the mean of exam score, they look alike. 1 point something. There's something point here actually, but so small. So you can see that the mean and the standard deviation of the exam score for the student using each studying technique is roughly similar. Not too far. I can see that they did 5.29, 5.16, and it's only out 6.04. So they are not too far, but this one also not too similar. And this one also not this one also they are close, 8.7, 8.4, 8.7, and the only this one that have a little bit margin, it's 280, 70. All right, so I just have to explore to see what we have. So we can also visualize, okay, not only explore that, we can also visualize by plotting to see how they are affected. So we can use a ggplot, or you can use a ggplot, use postplot to explore and see what you have. So let me just run this. So we are passing our technique here as x-axis to be on down, right? Exam score to be by the left hand side vertically, right? So that you can see, then you can fill in by technique so that you can color it, so that it will have different color for technique. Okay, so we don't want to see the legend because we already have the color using fill. So legend can be hidden here. So we say show legend for the force. Understand that? So that is simple to understand. So let me just zoom out. So what is what we have? All right. Okay, let me just okay. It's easy to you can declare this in here. Exam score by studying technique. This is by studying technique now. Okay, we have exam score. We have score here. We have technique here. You can see them. You can see the mean. They're not the same. Exactly the same. Even though they are this one and this one, they are very close. TFT, TMT, and TPT. All right. So if you also want to, you can also show for the current grade. This one just for the exam score. So current grade, you can also plot for current grade as well. Same thing. So for current grade, we have current grade here, technique here. You can see this one show a lot of differences. All right. So these differences, we can see that there are differences, but I want to know these differences, are they statistically significant? We want to show. So let us first check our assumptions now. Okay, we want to look at a linearity assumption first. All right. We create a scatter plot between the covariate now, we current grade and outcome variable exam score. So let's say we want to plot a linearity with plot. We want to use a facet to pattern wrap to do this so that to make it more neat. Okay, so we pass our studying the data set here, our data set name. Our x-axis is current grade, right? Okay, our y-axis is a exam score. So these are two numerical variable we have there. Okay, then we want to color by technique. That is our grouping variable. Okay, now we want a scatter plot geopoint. So you want to geosmooth to be linear model. Okay, linear model. So we have a straight line across each of the scatter plots. Right. So we want to facet wrap it so that I can break it into techniques, different techniques. So we have a TFT, TMT, TPT, different group, so that they will not be clutched together in one place. All right. So we want to just put a title there. So as usual, so this is just a team. Okay, so let's run this line and see what I'm talking about. All right, you can see here. So you can see it's very clear now. So looking at it from here, we have this is TFT, TMT, and TPT. So you can see that the exam score is a grade is here. You can see that there's a relationship between each of the group. For this particular TFT now, exam score and current grade, there is a relationship. Okay, you can see them for each group. For each group. Can you see? Right. If you can also check, you can also check the correlation. Okay, just to check, you can still check the correlation as they are linearly correlated. You can check. Okay, let's just say we want to check correlation now. Look at it. So this is what we have here. All right. I think this one is too long. This particular title, but never mind. All right. So let's check for the correlation. Let's see the correlation result here. Just use piping. Okay, we group by technique, then we summarize. Correlation equals to core. We pass our core here. Okay, current grade, exam score. We are going to look at the two together. So let's just run this. Okay, let's look at it here. So TFT we have having the highest correlation coefficient, and the TMT have the lowest. Okay, so you can see. So take note of this TFT as we proceed, and TMT. You can see something very common among them. Okay, so just take note. All right. So let's continue. Let's check normality check now. Normal distribution if they are normally distributed. So studying, we have part of our studying group. Okay, we want to use Shapiro test. So we group by technique also. So we pass our current grade and exam grade for two of them now. So we run this line code. So we look at the Shapiro test. So of course, all the tests should not be we should know. We do not say we must pass all the tests. Okay, at least, but we must not violate all the tests, because like I said before, parametric test is very robust. Okay, you don't need to meet all the assumptions for you to perform parametric test. That's what I mean. All right. So, but you need to meet necessary ones. So now look at this. Now you see here, we still have Shapiro test being met here. Only few. This one is okay. Okay. All right. This one is okay. 0.12. Okay. This one is also okay. 0. This one is not that. It's 0.4 according to 0.5, approximately 0.055. Okay. 0.05 approximately, which is not too bad. This one is okay. This one is okay, right? Only this one, right, is significant, right? This one is okay. It's okay. So you can see that we can also meet our parametric test here for Shapiro. Okay. So apart from this line, TPT for current grade that is significant, which is fail the assumptions, but the other ones are okay, right? So let's look at homogeneous of variance and see using a car. Okay, you can run the car here in library. So we conduct 11 tests here. Okay, pass the exam. Don't worry, don't forget that our technique has been factored. Don't forget it, because it requires your technique is factored. If not factored, it will give you some warnings. Okay, even though it's still run for you, but it gives some warnings. So you need to be factored. You just apply factor here if not, and the close bracket. But now we have already factored it from when we are creating our data set. So just run the 11 test here. Okay, let's click on run. 0.67, which is greater than 0.05. So this is accurate now. So go to 0.739. All right. So which indicate that the variance among the groups are equal. All right. So what are homogeneity of regression slopes? So we want to look at that also. So studying, we can just pass our studying here. Okay, we run an ANCOVA test by piping, right? We multiply this together. Look at by looking at the interaction here. So we run this line of code, right? Let me just put this on properly here. Run again. Okay, so we have effect here. So we have our p value here. So this technique here is significant. All right. Okay, we are giving, so you can see here technique is significant here, but the interaction is not. So what are looking at interaction now, which must not. Okay, there was a majority of regression slope as the interaction term was not significant. Okay, so don't forget. Remember when I was explaining the other time under assumptions. Let me just run down the SOC to show you again. Assumptions. We have talked about homogeneity of residual. Excuse me. All right. As I was saying now, we are trying to explain this homogeneity of residual variance here for all groups here. Okay. At a was it that one I was talking about now? I was explaining something now. Okay. Homogeneity of this regression slope. The assumption evaluates that there is no interaction between the outcome and covariance. So there won't be any interaction between them. So interaction must not be significant. That's what it means. Okay. Take note. Interaction between the outcome is a response variable and the covariance should not be significant. That's what it means. So let me go back. Let me come back here and again and continue from what we are doing. Sorry for the interaction there. So here, okay, we have done left. So okay, that is it. So you can see that it's not significant. We have a 0.0 0.09. Okay, you have value 0.093. That's what we have. So it's greater than 0.05. So it's not significant. And we have 84, 2. Then we have our F is 2.44. Okay, so that's not important for now. Okay, all right. So that is what we have, and that means we are able to meet almost all the assumptions actually, which is not necessary. We must meet all of them. Okay, so outliers. What of outliers? Let's see how do we do that. Let's pass our data set here, piping. So we group by technique. Okay, then identify. We call this function. Identify outliers. Current grade. We pass our current grade. Also, we also do for exam score. So we want to see. Okay, let's run this and see the result. So no row length, which means there is no extreme outlier, no outlier at all. If there's an outlier, it will show us, and if there's any extreme, it will let us know. But that means there's no outlier at all. So there is no outlier in data set. So let's now go and perform our one-way ANCOVA computation. Then you can compute our one-way ANCOVA. Let me just put this one down here so that I can see properly. So let's fit the ANCOVA model first. ANCOVA model, we call the function AOV. We pass our exam score, which is our response variable. We now with our technique now, which is our factor variable, group variable, then plus grade. Okay, that is how. Or you can put this one here, is correct. Okay, to work. Okay, so you can run this line first. All right, so this is we can now run the ANCOVA type 3. So we have our technique here, significance. We are interested in this technique. Okay, this line, right, is significant. All right, this is what we are most interested in. This. All right, so or we can also pipe in our using ANCOVA test method. Another method now. At the ANCOVA test method, we are piping our this thing here, and you don't need to pipe. You can also run directly without piping, but at least piping seems to be very interesting for me. Okay, and just piping here, just run this. Okay, and we pass the same thing we pass here. Okay, just passing the same thing here, not a difference. Okay, our studying already been piping, so we don't need to put it anymore. All right, so we can just pipe ANCOVA test here. Instead of using an AOV here, this is another method, ANCOVA test. All right, so we just run this now. We can run this line of test. There's another method. We can just pass our ANCOVA table here into the result table. Just run this. So we have this one is major one. Okay, that one is one give us only what we need. Okay, current grade and technique. Okay, so our technique here is also significant. Okay, which is 0. Can see. Okay, highly significant. The same way this one was significant here. Technique, can see. This one was so significant here. Right, so you can see. I think they look alike. Let me see. I think they look at this 8.67 per 6. 8.67. Oh, same. Wow, that's great. What of current grade? Let me add this same also 1.8928 current grade. Okay, they are not same, but this one just same. But that's what we are interested in. You can see we're interested in this. So and it's exactly the same with this. Okay, so which means that our technique is significant. So now you can now say we can see that the p-value for technique is extremely very small. which indicates that studying techniques has statistically significant effect on exam scores, even after controlling or adjustment for the current grade. All right, so we can now do post hoc test to know which one are, because now we can see there are differences now. There are differences. So we want to know which among these techniques that are different. Okay, which among them that cause the significant result we have, which among them. So we want to know. So although the ANCOVA result told us that studying techniques had a statistically significant effect on the exam scores, we need to run post hoc tests to actually find out which studying technique differ from each other. So let's load our library called multi-comp here. We fit in the ANOVA again here, just run ANCOVA model, call it AOVM. So we pass our exam score, technique, current grade. So we will have just passed that one here again, same what we have done here before. Okay. Just this one, the same thing we use here. This one is what we want to use here now. Okay, I just rewrite it again afresh here. Okay, that's not necessary. All right, because we want to pass in this one here for post hoc. All right, okay, using GLHT. All right, so for Turkey. But so now we just run this. I don't need to run this anymore, but I'll have used that one straight. But just to run afresh again. All right, run afresh again. We now pass we pass it here. Right, we call it post hoc. Okay, so this is our parameter we link feature. It's our choice technique here, so we call it NCP technique equal to Turkey. Right, so we run this line. This for ANCOVA now. Okay, so now we can now find the summary of the post hoc now. Right, summary. Okay, let's look at the summary here. So okay, so look at the linear hypothesis now. We have T. Now, the two significant one now is a TPT and TFT, TPT and a TMT. Okay. Let's see. Do you remember the other time I was talking about this TPT? Okay, let me see again. I was trying to look at the correlation the other time. Those that have high correlation that time. Let me see again. Let me see if I can run again. If I come back here. Okay, let me check. Doing our correlation. Okay, it's not the correlation. Okay, this correlation technique. We have a TFT, I, and TPT. TFT and TPT. TFT and TPT. TFT and TPT. So TFT. TFT, TPT. Okay, TFT, TPT. It's I, TPT, TMT. So, okay, I'm just trying to confirm what we saw in correlation so that I can know how to present it properly. So we have adjusted p-value now, reported single-step method. So now we have here two significant results here. Okay. This one is not significant for TMT for TFT. So we can actually, for this post hoc, we can actually conclude by saying that we can see that there is not a significant result, rather a difference at alpha equal to 0.05 between technique TMT, this one, and TFT. Okay. There's no result here, significant result here. Okay, but meanwhile, there is a statistically significant difference in exam score between studying techniques TPT, okay, and study technique TFT, okay, which is give us this one. We have a 0. As well as between technique TPT and TMT, which give us a 0.02. 002, not 02, 002, 889. So you can see that. So we can conclude that using study techniques TPT leads to a statistically significant greater exam score for students compared to techniques TMT. All right, and TFT can technique TMT and TFT even after controlling for the student's current grade in the class. All right, so we can reject the null hypothesis that each of the studying techniques lead to the same average exam score, even after accounting for the student's current grade in the class. So we can reject the null hypothesis now and take the alternative hypothesis, okay, that there is indeed a difference in the mean exam score. So which means that the exam techniques or the studying techniques rather has effect on the exam score. Okay. So this is just ANCOVA, ANCOVA, one-way ANCOVA. This method can also be applied to two-way ANCOVA. Okay. Just need to add additional one particular variable to it. All right. With the one we already have, then you can now perform two ways ANCOVA. Okay, that is just it. So it will make it work easier. So that means you are now looking at a one response variable now, two effect of two factors now on one response variable, while you are taking the covariance in consideration. That is what we just have now. So we will sit again in the next class when we have something else meaningful to do. So I will stop here for now. So you can go through it later and see how you can relate with this. Thank you so much for listening. If you are not yet subscribed, you can go ahead and do that, and you can see more of this as we continue. Thank you.